Good morning everyone. Welcome to Pantech Solutions, and I warmly welcome you for the session Robotic Operating System, that is ROS, which was organized by Pantech Solutions and ADAMA Science and Technology University, Ethiopia. So before going on to the session, I want to make sure are you able to hear my voice clearly? Is it audible, guys? Please tell me yes or no in your live chats. So I'm just waiting for your reply. Is it audible, guys? Is it audible? Good morning all. Good morning every respected professors, and good morning every students, as well as good morning to every hobbyist. Good morning to all. Yeah, thank you Purnima. Yeah, so before going on to the session, there is a little bit announcement. You just want to fill up the attendance form. Those link will be given in the description around 11:20 or 11:30 am. Okay, so just to continue on the session, so at around 11:30 you will have that attendance form link. It will be given in the description, or it will be given in the your live chat. Okay, so just please wait and please be attentive on the session. Okay, it will be available around 11:20 am. So then you can fill up your attendance form. Okay, so we'll move on. So about ADAMA Science and Technology University was first established in 1993 as Nazareth Technical College (NTC), offering degree and diploma level education in technology fields. And their schools and programs, they have School of Applied Natural Science programs, and schools of Civil Engineering and Architecture program, and School of Electrical Engineering and Computing programs, and School of Mechanical, Chemical and Materials Engineering programs. And about Pantech, it was established on 2004, and we are almost having 7 branches and 100 plus teams. And we are the manufacturer of lab equipment such as microprocessor development boards, microcontroller development boards, artificial intelligence trainer kits, and renewable energy labs, and motor and motor control driver boards and everything. And on the mechanical side, we are providing the solutions for robotics as well as mechanical designs. And we have conducted up to 1500 plus workshops and 250 plus faculty development program, and 100 plus seminars and 20 plus webinars. And our vision to gain global leadership in providing technological solutions through sustained innovation. Okay, so we'll move on. So these are the agenda. So first we are going to discuss about a robotic operating system. So you are all familiar with that word called ROS, right? So that ROS, what is mean by ROS, and why we are using that ROS, that is robotic operating system. And we'll move on to ROS system components. Why? Because there are a lot of components which is present in the robotic operating systems. So like subscribe topics like that, there are a lot of topics we need to discuss inside the topic called system components. That is ROS system components, so we are going to discuss with that. And then there are a lot of ROS version releases out there. Apart from like 2014 to some of the years, for every year they are launching a new version kind of thing in the robotic operating system. So we are going to discuss what are all the versions available, and then we are going to move on to tools of the robotic operating system. There are a lot of tools which will be available in the robotic operating system. So we are going to discuss about those kind of tools, and then finally we are going to discuss about the applications of robotic operating system. And I am going to show or give you a short view like how to create your own autonomous robot with the help of robotic operating system. Okay, so these will be very interesting. Like I'm gonna give you the suggestions and ideas to how to create your own autonomous robot with the help of robotic operating system. Okay, so these are the agenda which we are going to see today. Okay, so so what is meant by ROS? So you have already heard about it, right? ROS like that. So before, if you have seen a lot of robotics, so first of all, if you have seen first engineering concept, so first they'll use normal robots like line follower or human line follower. So those kind of only basic operations, right? Only mobile control robot or line follower robot. These are the only basic robot which is handled before 4 years or 5 years. but now they are moving on to the autonomous kind of robots. So robots have to be autonomous. It should automatically navigate through the path, and if I choose the destination point, it should automatically reach the destination point without colliding with any other object. So those kind of challenges are there. So robots such as robots is nothing but, so like if the user if you take a normal human being, they can't work for 24/7. So instead you can use a robots to deliver the packages, or by using a drones. The Amazon is having an idea patented, right? Do you know about it? They have that patent rights to use drones for delivering the packages. They have the project called the Honeybee project. That is kind of like honeycomb will be there. So from there, lot of numbers of hundreds and hundreds of drones will be going here and there to deliver the objects, or to deliver the like parcels and everything. So like drones and robots will be going to be the future humans assistant. So robots are becoming more advantageous. If you have seen Sophia, that is also a very advanced robot. Even Will Smith is dated with it. It is already speaking and laughing. It is having some kind of emotions, kind of like applications, and as well as it is speaking very gently. So those kind of robots, it gonna be the future assistants, right? So that's why we are moving on to the robots. So, and then what is ROS? So there are a lot of people are thinking like a robotic operating system is kind of one kind of actual operating system like Windows or Linux, Ubuntu. Not like that. It is kind of robotic operating system. It is called as a robotic operating system, but it is not an actual operating system like which we are using like Windows or Ubuntu or Linux and everything. But there its frameworks and tools, it will provide those kind of same functionality as like a operating system, for machine to machine communication, for those kind of application. So majorly it is used in robots, even though it will be helpful to have working or communication between two hardware peripherals. So if there is a two robots, or if there is some kind of sensor, if there is some kind of robot is here. Okay, so there we require some kind of communication. So for that we can use a ROS based technology to have ROS communication. It will be very helpful on the robots majority. Okay, so why robotic operating system? So robotic operating system, why means actually if you are having multiple machines or testing. So first thing, we have already heard about a simulation, right? So simulation is nothing but we need to test the hardware, or we need to test the working model. Why? Because if you are developing one robot, okay, if you are developing one robot from the scratch, okay, you are just use the motors, drivers, batteries and everything, you are going to make one robot, okay. But after making a robot, if you are programming it and if you are doing a test and trial, it may collide with walls, lot of battery losses, lot of problems you will face, right? So instead of doing that, what we can do is, with the help of ROS, there are a lot of options to do a simulation, visualization or testing and everything. So you can simulate a robot who is not familiar with the programming languages. You can simulate a robot with the help of robotic operating system, so that your robot will ready, or you can calibrate your robot in the simulation model itself, so that the model will be ready. Then as per the Simulink, as per the simulation which you have done, same simulation model, you can bring it back to the real-time model, real-time hardware, so that it will be very effective and it doesn't require lot of testing or lot of hardware changes. Why? Because if you are doing a hardware changes, it may cost you, it may trouble you a lot to choosing a proper and everything. So instead of that, you can do the simulation with the help of robotic operating system to have a better understanding or better creation of robots. And also there are a lot of options such as multiple machine communication. So if there is another machine, so it should communicate. So instead of normal communication by using any other serial wireless communication, you can use a ROS communication. It also uses a Wi-Fi kind of IP address and those kind of thing. So with the help of robotic operating system, you can simulation a model, or you can simulate one kind of robot or car or any kind of thing, and then you can bring it back to the real time robots. Okay, that's why we are using a robotic operating system. We'll discuss about detailedly why the main purpose is. Okay, and then what are the ROS system components? There are a lot of ROS system components are there. So for example, first thing, you just forget about everything, you just see only this publisher and then subscriber. Okay, let us take this normal YouTube channel. Okay, so what is happening? So we need one channel, right? We need one YouTube channel. Here Pantech Solutions, we just took one channel, YouTube channel named Pantech Solutions. Okay, so those who are all subscribed to this channel will receive the notification when I am beginning a new live, or when we have uploaded a new video. So you will get a notifications like Pantech Solutions, you have subscribed Pantech Solutions, so some video is uploaded in the Pantech Solutions. Do you wish to see that? So you will get a notifications, right? So this Pantech Solutions notification won't go for everyone, right? So the persons or the people who subscribed to that Pantech Solutions channel will get the notifications like message, like, so they are posted one video, just can you see it, like that. They'll have those kind of suggestion or those kind of messages. So that's the thing. So those who are subscribed to the certain topic will receive the message which is published by the publisher. Okay, so publisher is nothing but one kind of node or one kind of person. Okay, one kind of robot or anything. You can take publisher as one kind of sensor, or you can take publisher as one kind of robot. Okay, if you take a Lidar, okay, Lidar you know all about, right? So Lidar is nothing but one kind of sensor which will be helpful to do the mapping around the room or around the environment. So Lidar is light detection and ranging, so that will be helpful to avoid the car, which the collision of the car. Okay, so it will be helpful. So there is this Lidar, so we need to get the data from the Lidar to the robot. Okay, so for that Lidar gonna be the Lidar and some kind of controller or processor, that gonna be the publisher. So it's going to transfer some data, and on the subscriber side we can have MATLAB, or we can have any other robot, or your PC, or that can be the subscriber. So from the publisher, the Lidar values, the sensor values, or data, any data. So any data we are going to transmit from the publisher. So publisher going to publish some data, and in the subscriber side, who are all the subscriber side which are connected with the same network, they will connect with the network, so that they also receive the data from the subscriber side. Okay, so so this all the this will be helpful for publishing and subscribe. This is the topic, this is the one of the component, publisher and then subscriber. So publisher going to transmit some data, and the subscriber going to receive the data since they have subscribed to the same topic. Okay, so here what we will say, that topic, what the topic is. So here publisher going to transmit some kind of data from the transmitter, from the publisher side to the subscriber side, but we need to have a certain name for a message, right? So if you are sending any message, they will put up a subject, or will put up a message. What is the message content, or what is the message topic is, what the message is about. Is it a Lidar scan values data, or is it any kind of other sensor values data, or is there any other values like other sensor values? So we need to specify the name for a message, name or title or address kind of title for a message. So publisher going to transmit one data by having a common name. So that's the name where the subscriber going to subscribe the topic. So here if you take Pantech Solutions means, so Pantech Solutions is the topic. So subscribers should subscribe the Pantech Solution, so that only they will receive the same data. Okay, so publisher going to transmit something, so subscriber going to receive it by publishing or by subscribing the same topic, that is known as a topic. Okay, the name or title for a message. Okay, and then node. What are all the nodes are? Nodes is nothing but communication between one point to the another point. So here there is a one publisher, and we may have 5 to 10 subscribers. So here we'll have some kind of subscribers, right? So these are the subscribers. So this publisher is also a single node, and number of subscribers are numbers of nodes. So here one publisher and 3 subscriber means, so how many nodes? Totally 4 nodes. So these are the 4 nodes. The nodes, it can be it can be either publisher or it can be either a subscriber. Okay, so these are the nodes. So nodes means kind of points where the connection is where there is a connection. Okay, so these are the nodes. Okay, and then service and actions. Service and actions are one kind of services or one kind of action. If you are have the robot, okay, if there is a robot, we need to write the command to move the robot forward for 3 centimeter, and then it should turn left. So for forward, we'll write the code for as a service. So if I call the service of forward, service of backward, service of left, service of right. So those kind of commands will be helpful to move over the robots or a simulation, or while doing a simulation also to move over the robot you can create as a services or action. So we'll I'll tell you the difference between the action and services. So before that, you just understand a basic thing. So services and action will be helpful to have basic commands to make the robot to move forward or left or right or backward or stop. Okay, so these are the action which we have returned it, and then we'll activate the service to begin that service. Begin that action will be happen. We need to be happen in the robot. Okay, so these are the basic components. So publisher and subscriber. So there are the nodes, one node and then another node. So this node going to pass or transmit some kind of data in the name. That name is known as a topic. So it's going to publish. So in the subscriber side, we have to subscribe to the same topic, so that only we can able to receive the data from the publisher. Okay, so these are the basic things, and then we'll talk about detailing. So what about the ROS topic? So we have to know that the name which is required to have the comment between the subscriber and publisher to receive the data. Okay, so if you have taken this normal robotic operating system topics, so the topic will have the prefix slash. So if you have seen this, for example, so Lidar scan data is published in the name of ROS topic slash backslash scan. So this will be the topic format. So what the topic format is, it should have a prefix like slash and then scan. So here I'm going to transmit the Lidar's value. So Lidar is nothing but so it will, if we take a 360-degree Lidar, so it will identify the distance as well as the angle. So if you take a Lidar, so you have already heard about the ultrasonic, right? That is based on ultrasonic pulses. So like to calculate the distance or to calculate the obstacles in front of it. So if you have take a bats means bats, you know, no? So bats, the mammal, the bat, if you take it can't able to see clearly. So okay, so it will give some ultrasonic pulses. So if there is any obstacle, that ultrasonic pulses will hit that wall or it hit that obstacle, and it will be written back, so that it will identify there is obstacle, so we should not go this way. So it will turn it at the available solution, available path. So that is ultrasonics. So but if you are taking Lidar, that is based on a light. Okay, so it will give you the light. So from the light written back, so it will detect the distance of in the form of centimeter or in the meters. Okay, so here Lidar going to transmit some Lidar's data. So Lidar's data is nothing but distance and then angle. So you see, since it is a 360-degree Lidar, so for it will rotate continuously. So whenever that Lidar, no, so if there is obstacle here, so this is a 0 or 360-degree, and then Lidar will rotate like this, and then this is 90 degree, what is the distance, and then 180 degree, what is the distance, and 270 degree, what is the distance. So these are the Lidar data. So from the ROS topic, by using the ROS topic scan, the publisher or Lidar going to transmit the Lidar data in the name of /scan. Okay, those who are all those who are all needed the data, they will subscribe to the same topic name, that is /scan. So they will subscribe to the same topic, so that they also receive the data. Okay, so that's the ROS topic. So on the ROS topic, there are a lot of options or commands we can use it. So if you have typed ROS topic the space list in the terminal, if you have installed the robotic operating system in your Linux or Linux based Ubuntu, so you can give the commands called ROS topic list. So it will give you the topics, what are all the topics available. So if you are using multiple number of sensors like Lidar, by having a /scan name, or by having odometry in the name of /odom. So like that, if you have used a multiple number of sensors, so multiple number of topics will be there. So this ROS topic space list will give you the data, or will give you the number of list of ROS topics. So /can / odum. So these are the available topics which in the same network. So this is the first thing. And then ROS topic info space topic name. If you are giving a specifically the name ROS topic info space /can, if you are giving those kind of example, it will give you the format, what kind of messages. It will give you the information about the ROS that topic messages. So if you are transmitting the Lidar scan values, the scan values is transmitting in the name of /can. If you want to know what is data is transmitting in the name of topic /can means, you can type this command like ROS topic info /can means it will give you the data, what kind of data is, that is a sensor messages laser scan kind of data. So it will give you the format of it. And then if you want to print, if you want to see the data, okay, if you want to see the data, what you can go is, you can run this command like ROS topic echo /can, so that it will give you the information of the data. So it will give you the complete information or complete data which is streamed in the name of /can topic. Okay, so you will receive the every data. So for example, if I am transmitting Lidar scan values data, if I am typing the command called ROS topic echo /can, it will give you the distance 22.00, angle 360 degree, again distance, again angle, distance. Why? Because it is continuously rotating. So again and again it will give you the data continuously. So these are the basic commands for ROS topic list and ROS topic info and ROS topic echo. Okay, and then ROS node. So we have already know what is the node is, right? So there are some kind of communication between each and everything. So one node, so it's going to be the publisher, and we are going to have three subscribers. So totally 4 nodes we are having this 4 nodes. Okay, so with the help of commands known as ROS node list, so it will give you the available ROS nodes. What are all the nodes are available? So it will give you the number of nodes. So these are the first nodes. If you are using a MATLAB as a subscriber and publisher as a your ROS, so it will give you the nodes such as ROS master is your Ubuntu PC, and ROS subscriber, I have seen one subscriber in the MATLAB software packages, that is in the MATLAB I have seen this is one kind of one of the node. So it will give you the number of list of ROS nodes. Okay, and then if you have seen RQT graph, so RQT graph is nothing but it will if you type the ROS node list, it will give you only the list what are the nodes available. But if you have seen the RQT graph, it will give you the complete connection diagram, like tree diagram. So this is the one publisher, and this is the another publisher. One publisher is transmitting the Lidar value, and another publisher is transmitting the odometry, that is odometry sensor value. Okay, here we have used 3 subscriber. 2 is connected with this one, and another one is connected with this odometry. So it will give you the tree structure. So this one dot, so it is there will be 2 lines. So one subscriber and another subscriber is connected with this node, and another node, the first one is connected with that node. So like that, it will give you the tree diagram. So that is known as the RQT _ graph command. So it will be very helpful to visualize the connections of ROS communication. Okay, and then services. So what are all the services we have already seen? It will be helpful for calling a certain kind of function to move a robot, or to stop the robot, to turn left or right of the robot, right? But here there is one challenge. So if the robot is there, okay, if you may take it as in a Simulink, or you may take it as in a basic your real-time car. Okay, so now if you have if you are going to give services, okay, now you are going to give us services. So on that services, now what I am going to give is, I am going to give the information to the car to move forward. Okay, so the car start moving forward. Okay, so likewise car is moving forward. So while moving forward itself, I am going to give the command called turned right. Okay, but in the services, only after it moving forward for the certain period which we have assigned, which we have allocated already, then after completing that moving forward services only it will turn right. Okay, can you able to identify the difference? Actually, so the car is moving forward. I gave the command the services to move the car forward for 5 centimeter. Okay, so now it is in 1, 2, 3, like that it's moving. So while reaching at 3 itself, I am giving another services to turn the car right. Okay, but this services, if we are developed that code in the services, it will start moving further up to until it reaches 5, it won't turn right. After it reaches the 5 centimeter which we have allocated, then only it will turn right. Okay, so the services is that's the thing. So it is the based on the services. I think we have collided or we have jumbled, right? So the car breaks the current services and to do the latest service command. I just twisted. Okay, so car will break the statement and it will turn right. So here, for example, there are some kind of services command. So if you are using a ROS based your Ubuntu PC, so if you are going to start the services, so here first we have to launch the services in the one terminal, and the another terminal we have to start the function. So first we have to start the services in the one terminal, and the another terminal we have to start or we have to begin the we have to call the services. So first one is launching the service or beginning the service, and finally we'll have ROS services for calling the function called moving forward or left or back. So and then actions. So if you take actions, it is also looks like similar to a services. Okay, the main difference between the action and services was when you call a services, the robot has to wait until the services has ended before doing something else. So that's the thing. So action won't stop until it reaches that previous services or previous action. So like if the car is moving the same, if you take a 5 centimeter, so it will moving forward. Okay, so it will moving forward. Now it reaches to 3 centimeter. So while reaching a 3 centimeters itself, if I give the command to turn right, suddenly it will turn right. Okay, suddenly it will turn right. So that's the thing. So it will break the statements and it will turn right. Okay, so these are the basic commands which will be helpful or which is needed to be posted in the first terminal to launch the demo or to launch the action, and then another terminal I am going to call the function of ROS launch to begin an action to turn left or turn right. Okay, so these are the actions. Okay, so okay, and then ROS version releases. So if you have seen here, there are a lot of version which is started from I think 2010. So they have started with the box turtle and sea turtle, diamondback. So these are a lot of ROS versions which is available. Actually, there are 2 ROS, that is ROS 1 and then ROS 2. Okay, so on the ROS 1, these are the versions with the year of started. Okay, so 2010, from the 2010 here up to 2020 we have Noetic Ninja Mesh. So these are the latest version of ROS 1. But we have used Melodic, Marina and then Kinetic. So these are all very popular version of ROS. This Melodic, Marina and then Kinetic came, and then Indigo, Igloo. Okay, so these are the basic version which we have used more and more. Melodic, Marina and Kinetic came. Okay, and then if you are going to ROS 2, so there are also ROS tools. They have started at 2015, and in the latest June 5th to 2020 they have introduced Foxy Fitzroy. So these are the basic versions, basic version like ROS version release, which has happened in the ROS as well as the ROS 2. Okay, and then tools of ROS. So what are all the tools of ROS? What are all kind of thing which we can do with the tools of robotic operating system, which is making that to be a perfect operating system. So first thing, always So I hope if you are worked in that, you have that details, right? ROS means that is one kind of display kind of tool. It is having a three-dimensional visualizer. This will be helpful for visualizing the sensor values or data. Let us take same Lidar value. So I hope you all know about the Lidar. Okay, so if you have keep the 360 degree Lidar, it will take the map of it. If it will take the map of the room in the two-dimensional, there are two-dimensional Lidar also there, three-dimensional Lidar also there. So if you are taking a two-dimensional Lidar, so it will take out every values of the room. So on that room, what it will do means, with the help of ROS display, ROS, that is three-dimensional display, we can able to visualize the real-time graph or real-time map of the room with the help of ROS display. If you want, I can give you the link of our previous YouTube video where we have done this Lidar based ROS visualizing with the help of ROS display. Okay, so and once the session completed, I will give you the link. Okay, so there you can see the real-time presentation. I will place the Lidar here. So it will take over the every map of the room and it will plot in the ROS display. So that is one kind of very best tool for visualizing the data which is obtained from the sensors. Okay, and then ROS bag. So ROS bag is will be helpful to record or play back the ROS messages. To record the messages, so like you need a storage, right? So we have already heard about the storage. We have already heard about the storage, right? We have to save the messages, or we have to play the messages again which is recorded previously. So those kind of application we can do with the help of ROS bag. Okay, and then Catkin. So Catkin means it is also one kind of collection of CMake macros. So I hope you all heard about or worked with CMake, right? See, these kind of libraries, we'll use CMake to install heavy libraries. So we'll use the CMake to build the ROS packages in the different platform of robotic operating system. So that Catkin will be helpful for installing or building the packages which they have already developed. Okay, so and then ROS bash, those ROS bash also will be helpful for it will be helpful for tools like which will act like a suit. Okay, which augment the functionality of the bash shell. So you know all about the shells, right? Like terminal shells, a lot of shells. It will be helpful to have a suite for every tools. And then ROS launch. So ROS launch also, ROS launch that is the major tools will be used. So if you have written the code in the C++ programming to move a car, to move a robot forward, to have a control over it. Okay, you are going to you have already written the code for taking the Lidar scan values or to upload the scan values. Okay, but if you are using that kind of thing, we need to launch the file. We need to launch the program which we have written in any programming, that is C++ or any programming languages. We have to launch that. We have to launch that ROS. That is, we have to launch that. ROS packages or ROS code which you have written it. Okay, so we have to begin that with. So that only we'll use ROS launch. So it will be helpful to launch the program which we have written already to start the ROS. Okay, if you have seen the before command, we have used a lot of times of ROS launch. So here we have launched the action. So ROS launch action demo. So we have launched the action file. Okay, so that's mean by a launch. Even though if you want to display the Lidar value in the ROS display, there also we have to launch that kind of ROS package, that file we have to launch it. So for that we can use the command called ROS launch. Okay, so these are for launching the robotic operating system packages. Okay, and then ROS in MATLAB. I hope a lot of people are very familiar with MATLAB programming. Right, MATLAB, you have already heard about it, right? So if you have seen the latest version of 2018 or 19 or 20, there are a lot of options which is robotic operating system software packages is available, guys. You can install the 2018B or 19B. You will have that add-on boxes. Okay, there you just go there and you just install robotic operating system software packages. The software packages will be helpful for interconnecting your MATLAB with the real-time robot. So if there is one robot, okay, it is in the ground. So if you want to connect with the MATLAB, if you are very familiar with MATLAB programming, if you want to control the robot or taking the Lidar value to the MATLAB, means you can use this robotic operating system software packages, so that you can connect that robot with the MATLAB. Okay, so that's the MATLAB software packages. It is already available. You can check it out. If you are beginning with MATLAB, so there are a lot of commands like ROS init for robotic operating system 1 package. If you are using a robotic operating 2 software packages, that ROS init command is not required. So only thing is the robot and your laptop should be connected to the same network. So from there you can create an environmental variables to connect with the robots. Okay, so here we'll have set NV of ROS IP 192.168.1.6. This ROS IP is nothing but the system where you have installed the MATLAB. Okay, so this NV, this is the MATLAB command, guys. ROS IP, which resembles that IP address of the system where you have installed the MATLAB. Okay, and then ROS host name. So that is 192.168.1.6. So that will be helpful for, that is nothing but the ROS host name is also the same PC's IP address. Why? Because here we are going to act as a host. Okay, so that the two IP address are the same of the system where you have installed the MATLAB. And then ROS master URI HTTP 192.168.1.12. this IP address is different, right? So this is the IP address of the ROS or robotic operating system which we have installed in any robots or any robot. Okay, so that is ROS master URI. Okay, which we should configure these 3 commands to start the robotic operating system in the MATLAB. Okay, and then these are the thing. Okay, so these are the IP address, and this 11311 is a port number. Okay, port number which we are using for this ROS based communication. Okay, so these are the basic settings for robotic operating system MATLAB. Okay, and then we'll have this applications of robotic operating system. Okay, okay, so here autonomous robots. So first application is the ROS robotic operating system is used in lot of robot making for self navigation, for trolley, for maintaining stocks. So those kind of operation, it will be very helpful. The best example is a turtle bot. So here there is a turtle bot 3 burger, waffle and waffle pie. So these are all different versions of turtle bots. So you have already heard about the turtle bots, right? It is very expensive, but it can able to do the autonomous based application. It can navigate through every path, and it will support that ROS operating system. You can simulate this robot and then you can check that robot to work on in the real-time manner. So this will be helpful. So this is the major robots which they are using. Okay, other than that there are a lot of robots also there which uses robotic operating system. So normal ROS will be helpful for maintaining the robot. Not only this turtle bot, they have used a lot of ROS for any other real-time robot for picking up the object or for walking, for any kind of application. So if you are using kind of real-time robot, you can make to be very practice, like you can teach the robot to how to walk. Like you have to keep the left foot first, and then right foot first, and then left foot first. You should not shake that one. So like that you can teach in the simulation itself with the help of robotic operating system. Okay, so that's the main advantage of this robotic operating system. Okay, so and then okay, so here I'm going to give you the little idea of how to create your own robotic operating system, that is autonomous own ROS robot. So if you have seen this robot image, so here it contains a Raspberry Pi, and here we have used RP Lidar A1 model. There are a lot of RP Lidars are available. There are a lot of Lidars are available. This Lidar which we have used is 360-degree RP Lidar A1. If you want this Lidar, you can purchase from our website. We will share you the link to purchase the Lidar also. Okay, and then we'll designed this car using acrylic sheets, and then we have connected the motors and everything. Here we have used a power bank and then Raspberry Pi. I hope you all know about a Raspberry Pi. Raspberry Pi is kind of a mini PC. So this is one kind of robot. So here there is a Lidar. Okay, here this is the autonomous robot which uses a robotic operating system in the Raspberry Pi, and with the help of MATLAB we are going to do autonomous based application. So these are the working model, or these are the block diagram of the robotic operating system. So if you have seen the car, what the components or object which is present in the this car is, so we'll have Raspberry Pi. On the Raspberry Pi we have connected the RP Lidar A1, that is 360-degree Lidar, it will rotate continuously, and then we have connected a power bank, and then for drive the motor we have used Arduino with the HC05 for Bluetooth, and then we have connected a driver. We have driver, that is L29 3D driver circuit, and then robo chases, and then 9-volt battery we have used. These are the hardware which is present in this car. And then what that is, with the help of Raspberry Pi we have booted the robotic operating system, that is ROS OS, in the Raspberry Pi, so that and then we'll connect with this to my laptop and with the car with the same network, so that it will communicate with each other with the help of ROS communication, which we have discussed before. And then here in the MATLAB I am going to do some kind of operation such as SLAM. I hope you all know about a SLAM, that is simultaneous localization and mapping. So if you have seen about a SLAM, that is simultaneous localization mapping, that is nothing but if the car is here, okay, it should take the map of every areas, right? So map is nothing but this is the mapping. Okay, so this is the mapping. So this is one, this is my room. So we just drive the car all every area, so it will take out the every map of it. So this is a SLAM. So this is only a mapping. Okay, inside that we'll do a localization also. Localization means it should also locate the car where the car is present in the map. Okay, so here there is a no localization, but the localization is nothing but if the car drives here and here, so that will be a line and tracking of the car. So that is a localization, and mapping, that is known as a simultaneous localization mapping, SLAM. Okay, so that is simultaneous localization mapping. And then path planning. So we before that we need to choose the destination. So from the MATLAB I will choose the destination here, car, if the car is present here, if I click this location the car should reach the destination, okay, automatically. So for the destination marking, and after that we'll apply a path planning algorithm and path following algorithm to identify the available path to reach the destination from the source to the source. So it will automatically do the path following concept also to make the car to drive on the same path which I have plotted before. Okay, so these are the operation which is happened here. This is explained detailedly. Okay, here. So what the communication, if you have seen this complete bunch, it is little bit confusing, right? So I'll say it clearly. Okay, so in the in the robot, these are the hardware which we have used. So the robot will be in the ground. Okay, so Raspberry Pi we have already boot a robotic operating system. So okay, so from the Raspberry Pi the Lidar values, no, so Lidar's distance or angles, so those data it will be transmitted from the Raspberry Pi to the MATLAB via ROS communication. Okay, from the MATLAB with the help of robotic operating system software packages will connect with the robot. Okay, so the now MATLAB is having the capability to receive the every scan values from the robot, scan values and the localization values. So we will draw, or we will plot the map, or we'll plot the map like this. So we'll plot the map like this in the MATLAB, and after that we'll choose the destination in the MATLAB itself for the user interaction. And then after choose the destination, the control commands will be sent from the MATLAB to the car with the help of Bluetooth, the HC05 and the laptop's Bluetooth. So it will send the control commands like forward, left, right, turn around, turn 90 degree, turn 20 degree, move forward, turn left, turn right, like that. That control commands will be given from the MATLAB to the car with the help of Bluetooth. Okay, so control commands will be sent like that. So it will be helpful to transmit some kind of data from the MATLAB to the from the car to the MATLAB, and then car will be make the decision where the car should move forward or left or right, and then it will move forward periodically. Okay, so these are the operation which will happening in this kind of robot. Okay, if you need the detailed information about this robot, I have already given in the description. Okay, so you just go through and you just go scroll. Second project is that one, it contains a video, I can show you that also. Okay, so 1 minute I can show that. So these are the link which I have given already. Okay, so in this video we have this path planning robot, how it works and how it everything. So if this page contains lot of projects abstracts and IEEE papers and PPTs and buy now options also. So if you click this buy now, so there kind of operations are done which is happening in here. We have explained clearly about the project, how it works and how it's using and everything. Okay, and then other than that I told you like how to use that how to use that Lidar based ROS visualization using ROS display. Okay, 1 minute, I just scroll and I'll give you the link. Okay, here I think it's not available. I'll share you the link. I can share you the link. Okay, once this session is completed, I'll share you that link also. Okay, you just go and visualize that how it's working and everything. Okay, so once I'll check again. It's taking some time. Okay, so I'll share you the link once I'm ready with it. Okay, you just go through this link. So it contains a lot of projects regarding this one. So this autonomous robots we have conducted, we have done it for 3 kind of robots. This is one is lamb robot, which only takes only mapping, not other process. Okay, yeah, that link here I think it is not there. Okay, and so I'll check it out and I'll update you in the comments below. Okay, so these are things which I have discussed. Since this ROS robotic operating system is very huge to explain, within 1 hour we can't explain each and everything. Okay, so this is a question and answer session. You can ask me a questions, guys. I am waiting for your questions. You can give it in my live chat. Okay. So we are having 10 minutes. So for questions, you can ask me a questions now. I am waiting for your questions. I would like to get guide on how to design sign language robot. Sign language robot. Okay, so I'll send. I hope you all have the contact of our Pantech solutions. You can ping them directly. Okay, so they'll guide you like what are the procedures and everything. What is Lidar? Lidar is light detection and ranging. That will be helpful for detecting the map or detecting the obstacle which is present inside the room. So it will be helpful for to avoid the obstacles. It will be helpful to do a mapping and everything. These kind of operation will be helpful. Can we connect MATLAB with the Lego robot? Yes, you can. Can we use Python with Raspberry Pi? Yeah, we can use a Python with Raspberry Pi. So we are using the network for data transfer. Why do we need a Bluetooth module? Yeah, this is also a good question. So here already we are transmitting the Lidar scan values, no? So we are transmitting the Lidar scan values from the Raspberry Pi to the MATLAB. So at the time, if you are transmitting another thing with the same IP, there may be some loss in the Lidar packages. So that's why we are sending a control commands separate manner in the separate different way. Why? Because Lidar scan value is very fast. For each and every second, there are a lot of values will be there, so it should not disturb the scan values. So that's why the control commands will be sent from the Bluetooth. How to use ROS in MATLAB? So if you have the MATLAB, you just go to the home screen, and there it will be available as add-on. Either you just go there, and either you just search for robotic operating system. So it will redirect you to the available software packages for robotic operating system. You just install it, and there are some kind of basic examples and syntax. You can click it and you can go through it. Make a webinar on details regarding the mapping by Lidar using MATLAB. Sure, we'll have the conduct. We'll do the conduct on those kind of operation. Since this quarantine, so we have everyone is locked in our home, right? So that's why we don't have that much that hardwares and everything. That's why we can't able to give you the live demo. So we'll arrange another session for robotic operating system to give you the demo of ROS based car with the real-time MATLAB, real-time robot. Instead of MATLAB, can't we use a Python? Yeah, we can use it only for interaction with the human being, like to see the map or to choose the destination there. That's why we have used a MATLAB. Please do a Raspberry Pi tutorial. Surely we'll do the Raspberry Pi tutorial from the scratch. Sir, can we make the robot like once we command it repeats the work which we have been programmed? Yeah, we can do that. Instead of that, make it to be autonomous, so it will be very helpful. Other than that, giving a basic commands. Sir, is it necessary to Raspberry Pi only, or what about Arduino? Arduino will be used here for controlling the robots or connecting the drivers. Why? Because the Raspberry Pi is already busy with that kind of laser scan. So that to reduce its computational power, we have used Arduino to handle the hardware like to move forward or left and right. How to install ROS in Raspberry Pi? There are a lot of options to install ROS in Raspberry Pi. If you want, you just ping me. I'll just share you the link. Okay. How robot measure the distance on real ground? Nothing but you will first of all, while doing a mapping, that is a manual process. You have to drive the car from the MATLAB, or you just want to drive the car through your mobile phone or your MATLAB. Lidar is always rotating, so with the help of MATLAB, you will drive the car throughout every path and every possible ways of your room or every school. Then it will take the map of every areas, and then it will record as a complete map, which you have seen at here. So it will take the map, so that for that you just want to drive the vehicle manually, so it will take the map like this. So make a tutorial on BZI and robotics. BZI actually we have conducted up to three webinars. You can check it out once. If you want another detailed version also, we can give it to you. You have to purchase that BrainSense for that live demo. Okay, so you can make sure you just check it out with our old video also. Okay. Do you have any questions, guys? I'm waiting for your questions. Ecological studies using Lidar. Please share how can I use ROS, share the different space bound Lidar. Okay, so we can share you the link. Okay, you can get it. Best source to learn ROS. Just check it out once in Udemy, but that won't be very helpful to handle at the real time. It's just better to work on real time. Okay, you just purchase one Raspberry Pi and hand work on it and install ROS robotic operating system, or if you have Ubuntu PC, you can install that ROS on Ubuntu. So you just have a hands-on. That will be very helpful instead of attending a blank classes. What are the recent development in robotics? There are a lot of developments, like to speak each other. If you take this coronavirus, it is going intense everywhere, right? So some of the industries is worked on one robot which is placed in the entrance of the hospital. So whenever new person enters, so it will automatically capture its face and it will have the records like what it is doing for you. Do you have breathing problems? And it also identify the temperature with the help of thermal camera, and that it will create a database, and after that it will make an appointment. And if the person same came on the next day, so it will say hello James, so this is an appointment, so you just go and meet the doctor. So like that it will give a suggestion. That the robot advantage is more and more when compared to previous things. What is the difference between binary package and building source? I didn't get your questions clearly. Can you ask me detailedly? Can we recommend students from class 6 and above to learn robotic operating system? Surely we need to do that. Why? Because nowadays there are a lot of things. Like students, now only we are only thinking like some kind of 6th standard student is why the 6th standard students we have to force it for. So like that, a lot of people are thinking not like that. If I take Tanmay Bakshi, so he is working in Google or Amazon. So a lot of kids are working now. They are start doing work from their childhood itself. So start motivating, initiating any work, artificial intelligence or robotic operating system. Start doing it. Why? Because so that only they will do the learning and they'll got interest. You have to identify their passion or their interest. So you just start giving them the ideas which is required for them. Yeah, ecological studies using Lidar. Please share how can I use ROS. Yeah, we can share you the link. We can able to conduct another session for robotic operating system at a real time with the hardware also. Since this quarantine makes us to use without hardware. So once the quarantine completed, we can conduct the seminar or webinar for based on this with the hardware also. Yeah, the same question. I didn't get your questions actually. What is the difference between binary package and building source? So building source is nothing but we have to write the code in C++ programming, and then we have to write to be run at the ROS launch. So there are only C++ programming which is written for ROS display and all. So we'll write the code and then we'll begin that file, or we'll launch the file with the help of ROS launch commands. What are the basic required to start with the robotics? For robotic, first you just start with a basic robot. Okay, you just purchase some basic robot and you just work on with the hardware, drivers, motors and those kind of operations. So like motors, like DC motor, servo motor, these two motor is more than enough for basic learning. So you just start with the robot, build up some robots like line follower or wall follower or obstacle avoidance robot by using some kind of sensors, and mobile control robot or joystick control robot. So these kind of robots you just practice on, and further you can move for Lidar and then robotic operating system further. Can you make a session on AI and ML for basic learning? Surely we'll make a session on machine learning, don't worry. We'll have that one, we'll have that session. Do you have any other questions, guys? No questions? So we'll have upcoming session on MATLAB. MATLAB and MATLAB with image processing, and MATLAB with other operations such as robotic operating system and everything. Okay, so these are the things which we are going to see later on. Yeah, IoT for Internet of Things, we have conducted already a webinar. Okay, you just go through and check it out once. Okay, for that webinar. So upcoming session will have like MATLAB with image processing. I hope a lot of people are working on the research to work on MATLAB with image processing. So upcoming session gonna be like MATLAB with image processing. This is not a confirmed one. Okay, so you just follow up us so that we'll have any session at any time. So if you have any doubts, you can directly ping it in the comment box which is presented below, so that everyone will get benefited. So other than that, if you have comments or personal queries or suggestions, you can ping me at sanjay@pantech.ai, or else if you have any queries regarding projects and products, you can go for www.pantechsolutions.net. Okay, so I hope you all cleared about the doubts. If you have further doubts, you just ping it in the comments below. Once this session is completed, the comment box will be released. Okay, so that everyone will get benefited. Okay. So thank you for watching this video, guys. I feel very happy to see your messages and questions and suggestions. I feel very happy. Thank you for watching this video, and if you just use this quarantine is for you and not for your learning. Start learning as much as you can. So follow up us, guys. So have your suggestion to your friends regarding these kind of learning. So share your knowledge with your friends with this help of these webinars. Since it's free, it is very easy to handle with 1 hour to get overview of every concepts on basic concepts. So it will be helpful, like after this quarantine ends, you will have basic knowledge on every technologies like robotic operating system, machine learning, deep learning, IoT, brain computer interface, so the chatbots, natural language processing. So those kind of thing you will have very great knowledge, basic knowledge. You just share to your friends, and if you haven't subscribed to our channel, you just subscribe to our channel and do the like and then share. And if you have any doubts regarding this session or any session do you want me to take for you, you just give me in the comment box. Since this since the live is going on, so comment box is blocked now. So once the session is completed, comment box will be released. So there you just give your suggestion to take a session